We've talked a little bit about our notation. Should we use the T subscript or not? We've talked a little bit about whether or not we should use returns or risk premia, and we've also talked about what we should use for our market proxy. Should we use the S&P 500 or should we use a broader market index like the CRSP Evaluated Index? What we will do going forward is whenever possible, we'll use risk premia and we'll use the broader market CRSP Evaluated Index. Most of the time when people are doing the CAPM, they tend to do just returns on the S&P 500. It's not great, and we'll try to do better. Okay, so what we're going to do now is we're going to add more variables to the right-hand side. We're going to add more risk factors to our model, more than just the market return, because we know that the market risk is not sufficient to fully describe returns. The CAPM isn't sufficient. Well, how do we know? Well, because alphas are systematically non-zero. We know that large stocks and small stocks and value stocks and growth stocks will have either positive or negative CAPM alphas. And so we'll see that other factors are priced. And this can be market cap, large versus small. It can be a relative price, value versus growth. And we'll see that other input prices like commodity prices or currencies or other economic factors are absolutely priced factors. So therefore, we'll add other factors to our model to better describe historic returns and maybe assess skill versus luck, risk-adjusted expected return, and to better calculate expected security returns. And then also we'll see that we can use these other factors to attribute realized returns to other factors as well. So the first multi-factor model that we're going to talk to is the most famous one, and this was developed by Ken French and Eugene Fama in 1992. They wrote a paper called The Cross-Section of Returns, and this is a most famous paper in finance in the last 30 years, arguably. And what they found was that it's not just the capital asset pricing model, it's not just the return of the market that seems to describe returns, but also a small stock premium. A premium for stocks that are small cap versus large cap. And the way this works is they measure this by market capitalization. They take the shares outstanding times the price, and they calculate this for all 4,000 stocks, and then they rank them. And the top third are the largest and the bottom third are the smallest, and they take the return of the smallest stocks and the portfolio of small stocks and the return of the portfolio of big stocks, and they call this SMB, or small minus big. And so this number is a return minus a return, and so it's a return. And it tells you the return to a portfolio in every month of small stocks relative to a portfolio of big stocks. The other priced factor that Fama and French wrote about in the early 90s is the value stock premium. And this is measured using book to market. It's the book value of a share of equity divided by the market price of a share of equity. And a stock that has a low price then has a low denominator, and so the value of the book to market is high. And if a stock is a growth stock, it has a high price. And since this is in the denominator, the value of the ratio is low. And so the value stock premium, just like the small stock premium, the value stock premium is the return to a portfolio of value stocks relative to the return of a portfolio of growth stocks, which we call the return of the high variable minus the return of the low variable, or HML. And so in every month, we're going to have 3 data points that we can use to regress the return of a portfolio. The first is going to be the return of the market minus the risk-free, or the market premium. The second is going to be the return of a portfolio of small stocks relative to a portfolio of large stocks. And the third is going to be the return of a portfolio of growth stocks relative to the return of a portfolio of value stocks. And so what we're going to do is we're going to do a backward-looking regression estimate, ex post or after. And so here's our model. We have the return of our stock or our portfolio, and now we're going to estimate not just a single beta, but 3 betas. We're going to measure the beta on the market, the beta on the small stock premium, and the beta on the value stock premium. So note that we now have subscripts on the betas to indicate each of the factors on all three betas. We have the beta on the market, we have the beta on the small stock premium, and the beta on the value stock premium. Now, similarly to how we drop the T subscript, we'll often drop the I subscript. Since we know this refers to whatever it is we're checking out, it's the market beta, the small stock beta, and the value stock beta. And here is what the forward-looking model looks like. Once I have calculated each of my betas, I can now relate these to an expectation of all three of these. An expected return of the market, an expected return for small stocks, and an expected return for value stocks. Given these betas, I can now calculate an expected return for a stock as a function not just of its relationship with the market, but whether or not it's a small stock or whether or not it's a value stock. And I can get a much better indication of maybe how much investors need to earn from investing in a stock. I can get a much better indication of the cost of capital to a firm, or I can get a better indication of what something might earn going forward. And so we'll go to the spreadsheet and we'll look at some calculations.